No matter where you live, it's usually much cheaper to buy a house right next to the airport than it is anywhere else in your city. And that's for good reason, because living next to an airport means you're interrupted by loud noises from early in the morning to late at night, or maybe even all night if you're near a busy international hub. You're exposed to all this sound and noise pollution. It sounds pretty crazy, I know, but this is a good analogy for what many marine mammals have to experience on a daily basis. This is the Langkawi Archipelago and its adjacent mainland coastal area, the Perlis and Kedah waters. Langkawi is one of Malaysia's top tourism sites, and together with its mainland coast, these areas are an intense fishing ground. As far as we know, there are three marine mammals that are commonly found in this area. They are the Indo-Pacific humpback dolphins, the Indo-Pacific finless porpoises, and the Irrawaddy dolphins. But these dolphins, they do coexist with fishermen, the tourists, and many different types of boats that are just zooming around the coastal areas from all hours of the day and even at night. A lot of people used to think that the ocean is a silent place, but it really isn't. It's actually bursting with sounds, from biological sounds from animals to geophysical sounds like storms, waves, ice, and earthquakes, and also man made noise from military boats to tour boats to fishing boats. Noise made during offshore construction, and also seismic surveys that's used to search for oil and gas. All of these sounds are bouncing around the same environment. And to make matters worse, sound actually travels 4 times faster and louder underwater than it does in air. So what you hear now, and like if you hear a construction noise on land, it's actually 4 times louder underwater. Can you believe that? So our question is, as scientists and researchers, is how does all this noise impact the animals that live underwater, and what can we do differently about it? I've been interested in dolphins ever since I was 10 years old. I saw my very first dolphin and I heard the word marine science. That's when I told my mom that that's what I want to be when I grow up. I want to be a marine scientist researching on dolphins. I guess you can say now I'm living my childhood dream. But I'm so grateful to have such a supportive family and friends that helped me get this dream. So that led me to doing my undergraduate in James Cook University in Townsville, Australia. During this undergraduate, I learned everything about the marine world. I learned marine biology, marine chemistry, and oceanography as well. But it was during this time I learned the word bioacoustics. So, bioacoustics is a combination of two words, that's biology and acoustics. So, biology being the study of living things, and acoustics being the sound. So, bioacoustics being the study of sounds from living things. I've I've learned so many things about bioacoustics, but one fact that really attracted my attention was that orcas, or also known as killer whales, they have dialects. Did you know that? When I heard this fact, I was instantly fascinated and I wanted to know so much more. I wanted to know if do all marine mammals make sounds? What type of sounds do they make? Do they all have dialects? I knew then that this is what I wanted to focus on, bioacoustics. So that led me to doing my master's degree in the Lighthouse Research Station with University of Aberdeen in Scotland. The research station was located in a very small town called Cromarty with a population of 700 people only. It was such a great experience, but I learned so much from the amazing research team there. They were all so inspiring, and I learned a lot about acoustics in my master's degree. My master's research was focusing on the offshore wind farm construction that was happening back in 2017, and I wanted to look at this construction noise impacting on the presence and absence of the harbor porpoises in that area. And what we found out was that initially, at the start of this wind farm construction, was that these harbor porpoises did actually leave the area because maybe the sound was too loud. But what we saw was eventually, after a few months, these porpoises came back to the same area, meaning that this area could be an important ground for these animals. Maybe it's important for breeding or foraging. So at the end of my master's, I wondered if there were any bioacoustics project on the marine mammals back home in Malaysia. So that's when I reached out to Dr. Luisa Ponampalam, one of the co-founders and chairperson of the Marasat Research Organization in Malaysia. Marasat is the first and only NGO in the country that focuses on marine mammal research and conservation. I told Dr. Luisa that I'm interested in researching the dolphins' bioacoustics, the dolphins in Malaysia specifically. And at the same time, Dr. Luisa had actually planned to expand the research and to include an acoustic component. The Langkawi Dolphin Research Project has been ongoing for more than 10 years now, and so adding an acoustic component will definitely help with increasing the information of the dolphin population in that area. So Dr. Luisa agreed to take me on as a student as part of the Marasat team studying the dolphins, but she also connected me with two other PhD advisors in Kyoto University, Japan, who are experts in bioacoustics and also have done previous work in Malaysia. And that's how I began my PhD project working on this project, where I look at the impacts of sound to the dolphins in Malaysia. To understand how these animals are impacted by noise pollution, first we have to consider what it's like to be one of them. For example, in Malaysia, in certain coastal areas, the waters are quite murky. Actually, not only in Malaysia, but many parts of the world as well. The waters aren't always crystal clear and blue. And also, the deeper you go, the less light penetrates. And so, murky waters and dark waters means you can't fully depend on your eyesight underwater. That's why marine mammals rely heavily on sound for foraging, communication, and navigating. They need sound to navigate, to look for direction underwater, and to also sense their distance from the seabed. They also need to use sound to look for fish and to feed themselves. And many marine mammals are social animals just like us humans, and we need sound to communicate, to socialize, and to maintain contact with one another. So, an example would be in seals, where mother seals would go to look for food and would come back to look for its pup from hundreds of other pups. So, this seal pup would have to call out for its mom, and the mom would hear its specific call. Different marine mammals make different types of sound for different reasons. Scientists have found out sounds such as whistles, clicks, codas, burst pulses, roars, songs, and so much more. Let me tell you about the loudest animal on this planet, the sperm whale, or also known as that whale that you know of in the story Moby Dick. Sperm whales can produce sounds of up to 230 decibels. Just for comparison, imagine standing next to a jet plane. That jet plane can only make sounds of 150 decibels. If you were underwater with a sperm whale right in front of you, their clicks could be so loud that it could knock you out. Let's listen. Sperm whales communicate through these Morse code-like patterns of clicks called codas. It's how they communicate with one another. It's also how they find their giant squid 2,000 meters under the surface where light doesn't penetrate. Each individual whale performs a personalized version of a coda, which functions like a name. One can make it quickly, like click, 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 or slowly, like click, 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 or maybe with an emphasis at the beginning or at the end, like click, 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 click. These codas help the whales identify their families and themselves. Dugongs, like the ones here we have in Malaysia, they make chirps and trills. Actually, I'm wearing a shirt that has a dugong on it. Let me show you. So this is a dugong. And the different types of sounds they make, scientists have found different reasons for it. Scientists think that the chirps are for getting attention from other individuals, for example, hey, I'm over here. Whereas trills might convey a more complex information like communicating their emotions or alerting another dugong of danger. These weddell seals from Antarctica sound like they're straight out of a sci-fi movie. Yep, that's what they sound like. The males are much louder than the females, and you can actually hear them through ice. Our current research focuses on dolphins, specifically the Indo-Pacific humpback dolphins and the Irrawaddy dolphins, like these guys. Let me share some fun facts about these animals. The Indo-Pacific's humpback dolphin, they are actually born gray in color, and as they mature, they lose their gray coloration and they turn pink. So they're also known as the pink dolphins in Malaysia. The Irrawaddy dolphins, they have this interesting behavior where they pop their head out of the water and they actually spit water, which is pretty interesting and pretty rare for marine mammals. We know from past research, scientific research, that the most common impact of noise on marine mammals are masking, behavioral change, hearing loss, stress, and maybe even death. Masking is the lack of ability to detect crucial sounds due to an increase of background noise. Let me bring it back to the example of the airplane. If you and your friend went airplane watching and the plane is about to land and the noise is so loud that it's you can't hear your friend or yourself talking. So that airplane noise is actually masking your voice. And that happens to marine mammals underwater too. So if a boat were to pass by, this boat noise could be so loud that it's masking the animal's communication sounds. So what happens? What happens when the airplane's landing and it's so loud you can't hear your friend or your friend can't hear you? Do you increase your volume, scream a little louder so that your friend hears you, or do you wait a little bit and stay silent? So this act of behavior is called behavioral change. And that happens to marine mammals. Marine mammals could either alter their change their frequency range so that it doesn't overlap with the boat noise, or they could even stay silent until the boat passes by. Some humpback noise studies have found that they reduce singing in response to noise 200 kilometers away. Another impact of underwater noise to marine mammal is hearing loss. Depending on how near or far an animal is from the source of the sound, the animal can experience temporary or even permanent hearing loss. Let me give you an example. If you were to go to a rock concert and you come out of the rock concert feeling like you can't hear a little bit, that is called temporary hearing loss. And that's what marine mammals experience too. Man-made noise can also cause stress in marine mammals. A higher stress level in marine mammals can reduce breeding success and also affect the health, which could eventually lead to death. A study showed that the metabolic stress levels in Ganges River dolphins in India increased due to an increase of vessel noise in the area. Studies have also found that loud sonar sounds from military practices offshore can also disorient and terrify marine mammals. These animals panic due to the loud noise and change their diving behavior, which causes diver's bend or, as we know, decompression sickness. Research on mass strandings have found that these animals are suffering from traumatic injury to their ears due to these military sounds. So these loud noises could literally scare a whale to death. Hopefully, that won't be the case for the dolphins in Malaysia, but we just don't know. So that's what we're studying now, how Irrawaddy dolphins and humpback dolphins use sound and how they're impacted by the noise pollution in their environment. Let me share a little bit about how we do our fieldwork and what we do for our research. So as part of the Marasat team in Malaysia, we would head out to the ocean bright and early in the morning and we would look for a group of dolphins. We look for the group of dolphins using our naked eyes and also binoculars. The boats that we use are fishing boats and tour boats, so nothing fancy, no fancy research vessels. And usually there would be about 4 to 7 of us on the boat, depending on how many volunteers we could get for that survey. And for our research as well, for fieldwork, we're usually all covered up from head to toe until up to our fingers and our face because we want to protect ourselves from the harsh UV rays that can happen out at the ocean. So when we're on the boat, we're out there looking for dolphins. It can be really calm. The waters are perfect and beautiful. And then suddenly you'll hear someone scream out, "Dolphin!" That's when we first sight a first group of dolphins. And what we do is for the first 10 minutes, we want to just observe these dolphins' behavior. We want to see if these dolphins are allowing our research vessels to be near them or if they're avoiding our boat. So if the dolphins are swimming fast and away from us, then that means they are avoiding us and we want to leave them alone because we're altering their behavior. If the dolphins allow us to be with them, then we continue our research. So after the 10-minute mark, we want to put down our hydrophones. So hydrophones are underwater microphones that we use to record all the sounds underwater. And each person on the boat has a specific role. So there'll be 2 people at the front of the boat that are in charge of taking photos of the dolphins, either 2 or 3 of us in charge of the acoustics, and there'll be 1 person taking down notes. We want to write down as much information as we can with the dolphins that we are currently with. The type of information that we write down are the number of dolphins in the group. Sometimes we see 2 dolphins to 50 dolphins, or maybe even more than 100 dolphins in a group. And so it can get really hectic, and we want to write down whatever we see. If we're with a big group of dolphins, everyone is looking at a different individual, and we can hear all sorts of things because we want to write down their behavior. So you'll hear some people screaming, "Oh, there's a baby in the group." That means that there's a calf in the group. So we want to write down how many mother and calf pairs are in that group. And then suddenly you'll hear someone scream, "Fish jumping!" Oh, that means that the dolphins are chasing the fish and the fish are trying to get away. So maybe the dolphins are foraging or looking for fish. And you'll hear someone scream, "Oh, breach! Leap!" That means that the dolphins are leaping out of the water or they're socializing. We also want to write down the number of boats that are zooming around the area and what type of boats they are. So we stay with this group of dolphins for up to maybe an hour, 2 hours, depending on how cooperative they are. And once we're done with that group, we'll have a break. So we usually have our lunch break on the boat itself. We don't go back to shore. We'll have our packed lunch and we'll eat on the boat out at the ocean. And if we even have time, we'll go for a little swim. No matter rain, storm, or sunshine, we still go out to the ocean because our study area is quite microclimatic. So, meaning that on shore it could be raining, but once we go out to the ocean, it could be sunny and beautiful weather. After our lunch break, we would continue looking for any other group of dolphins, and we would end the day either before sunset or at sunset. I think we see some of the most amazing sunsets on the way back to shore. Once we're back home, what we want to do is we clean all our equipment because salt water can get really corrosive and we want to avoid that. So we clean our equipment and then we download our data and we analyze all our recordings. What I want to see from these sound files is I want to look at the different types of sounds that we recorded, and I also want to look at the frequency, the duration, and the pattern of these sounds. I want to match up these sounds with the field notes that we were taking. So I wanted to see if, let's say, the dolphins were foraging, what type of sounds did they produce? Or did they produce more sounds when they were traveling compared to foraging? We also take into account environmental conditions such as depth, because dolphins can actually adjust their sound based on their environment. So maybe the deeper it is, the more sounds they produce. What we found so far are that there are 3 types of sounds produced by the Indo-Pacific humpback dolphins. They are clicks, whistles, and burst pulses. Let's listen to what a humpback dolphin whistle sounds like. And this is what their burst pulse sounds like. It'll be interesting to know if they produce any other type of sounds with more data collected in the future. Unfortunately, COVID delayed our fieldwork. We've only done one round out of 3 with the Morris Animal Foundation grant. But once we're done, the information from this project, along with past and ongoing project with the Marisat team, will be brought to the government to advocate for things like speed limit in the ocean. Right now, there aren't any speed limits for boats in Malaysia. Other countries and cities have instituted speed limits to help marine life. For example, Florida created speed limits to protect the manatees, not just from boat noise, but also from boat strikes too. And we also want to increase the awareness for the general public in Malaysia. Many people in Malaysia actually don't know that dolphins and whales exist in our waters. And many boats don't know what to do when they see a group of dolphins. They'll go either really fast or they pass in front of a group that's swimming. Based on what we find, we can create a set of best practices for the general public so that they can enjoy the ocean safely and in a way that's more friendly for the wildlife out there. But for now, the best thing you can do to protect marine life is to change your own habits and activities. When you're vacationing on the coast, consider renting a kayak instead of a jet ski, or maybe a sailboat instead of a speedboat. Slower boats are generally less disruptive to the wildlife out in the ocean, and you'll get a better view of them that way too. If you do see a group of dolphins or whales out at sea, please remember to slow down or tell your boat driver to slow down and remember not to pass across their path. And finally, remember that everything you bring out to the ocean must come back to land. One of the best ways to keep animals safe and healthy is to avoid polluting the ocean. It's already bad enough as it is. Protecting marine wildlife isn't difficult. It just requires a little bit of effort on our part. Before I end my talk, I'd like to share a quote by Jane Lubchenco. The oceans are not too big to fail, nor are they too big to fix, but the oceans are too big to ignore. With that, thank you very much for listening.